Hello and welcome to my latest blog post. Thank you very much for dropping by my blog post today. I really appreciate you dropping by, so thank you very much for that. In today's blog post, I want to address a number of aspects of the product and processes being promoted by Incorta. I have sat in on a number of their presentations recently, and they are creating quite some buzz around the industry. I'm sure that they have some happy customers who are able to do things they never thought were possible before, and that's great. For more than 30 years, I have promoted data warehousing and BI, and I would like to see more successful projects and fewer failures, and as few as possible outright disasters. Yes, gentlemen, we see plenty of outright disasters. I am one of the most experienced people in the world in the area of ETL and data models, underlying analytical applications that deliver the foundation for sustainable long-term profit growth for companies. Long sentence, but I really am one of the most experienced people in the world at that. In fact, I was talking to an old friend of mine the other day, and he mentioned that now that Ralph Kimball has retired and the two men who helped train me are not public figures, I would be the world's highest profile man talking about dimensional models in the public. When I thought about it, he's probably right. There's no one else out there publicly talking about leading edge dimensional models and how to build them who has anywhere near the experience that I do. So, if you do not know what Incorta is, you can go and watch a demonstration on the button below. And of course, there's a button on the web page. This blog post is for people who have seen a demo of Incorta and are considering the product. It is also for those who have the product who are facing the rather predictable issues that will come with trying to do what Incorta is recommending. So, firstly, what is Incorta recommending? What does their product do, basically? Well, basically, the Incorta product is a GUI-based and simplified way to copy data from some operational system, usually ERPs or cloud-based services, and to deliver that into a cloud-based Parquet database. Then, on top of the Parquet database, to be able to run queries through a metadata layer that makes the underlying copy of the source data somewhat understandable. Sure, there is a bit more to it, but that's the gist of it. 1. Copy, replicate data from ERPs, cloud services, into another cloud database using the same models as the source systems. 2. Put a metadata layer over the top to simplify the underlying model to some extent. 3. Query that metadata layer like it was a real model useful for BI. 4. Make it all go fast because it's on a columnar database. Now, as I have said, Incorta may have many happy customers, and those customers may like what they have. That's not my point. The purpose of this blog post is to point out that what Incorta is doing has been done many times before. It is to point out that there are reasons why Bill Inman, Ralph Kimball, and myself have not recommended that companies build data warehouses like this for more than 30 years. The top line reason is they don't work properly, but we will go into some of the details. So, in the early 90s, Bill Inman defined the data warehouse to be a subject-oriented, integrated, non-volatile archival data store to be used for the purposes of supporting the management decision-making process. In 2008, Bill brought out his book on Data Warehouse 2.0, which extended the ideas of what could properly be said to be the data warehouse and what were all the components of the data warehouse. So, let me be straight. Prior to 1997, it used to be pretty hard to build a data warehouse. The bit that was time-consuming and expensive in people terms was building of the ETL systems. But in 1997, I invented a new way of designing and building ETL systems. In that year, I did what I would call my first second-generation data warehouse, using everything we learned from 1991 to 1997. That included the then COBOL version of what has evolved into what is now CTL. We built the data warehouse for Manulife Hong Kong for the services fees of just 300,000 US dollars. This was about the same cost of Bill's Prism software at the time. Basically, I had invented a way of generating COBOL code as the ETL system that reduced the development time down to about 1 work month per 500 fields mapped through to the data warehouse. In 2003, a colleague of mine invented a way to get 1,000 fields mapped through to the data warehouse per work month in the ETL development. Full disclosure, I didn't actually invent that, okay? But hell, I took the idea because it was a good idea. We stayed at the 1,000 fields per work month until 2018 because no one else was even close to that productivity rate, so there was no point going any faster. In 2018, we finally invented a way to get to 6,000 to 8,000 fields mapped through to the data warehouse per work month. We are looking for AI or other means to improve on that as well. But even quite large improvements on that rate are quite meaningless now. The fact is today in 2022, and it's May 2022 as I'm making this recording and updated the blog post. The fact is today in 2022, the cost of building ETL for a dimensional data warehouse is so low that it is no longer a major portion of the overall budget. The maintenance of the ETL is also no longer a major portion of the overall budget. If you are paying a lot of money for the development and or support of ETL, then you should talk to me about what it is you're doing. It is very likely one of my customers using my software can do the ETL development or support for you much cheaper than you can do it for yourself. One of the major arguments Incorta is making is that the cost of ETL to build the data warehouse is high, and so if you use Incorta, you will avoid that cost. I can tell you that the cost of building and supporting large complex data warehouses from ERPs is now counted in the range of 6,000 to 8,000 fields per work month in development. Indeed, I would do that work for $8,000, today's rate $8,000 per work month if you wanted to hire me personally. That is about 30% of what I was charging to do 1,000 fields per work month 10 years ago. So I just want to emphasize this point, gentlemen. If you want me personally to build your mappings for your dimensional data warehouse, I will charge you $8,000 per work month and guarantee that will be 6,000 to 8,000 fields mapped per month, after you learn the thing in the first place. This isn't a from day one thing, right? And I want to contrast that with 10 years ago, over 10 years ago, I stopped being really active in the warehouse space 10 years ago. I was charging between 1,000 and 1,200 euros per month to map 1,000 fields per month. Okay? And the public customer that I can talk about is TalkTalk, and they had 4,000 fields to be mapped, source to target, and I mapped those 4,000 fields, plus training people, plus managing the project, and all the other things that I have to do. I did those 4,000 fields in 4 elapsed work months, and I think my rate was like 1,200 euros a day. I can't be sure, but it was something like that. Okay? So if you calculate the cost of building your ETL on the basis of 1,000 fields mapped into the data warehouse per month, I can deliver at least 18 times, that's 18 times better pricing than I was delivering 10 years ago, just 10 years ago. Okay? Now, if you can't get anybody else to build your ETL systems that cheap, you want to talk to me. If you can't get anybody else to support your ETL systems very cheaply, then you want to talk to me because I've got a whole bunch of customers around the world who can do that for you cheaper than you can. All right? So 10 years ago, we were already the lowest cost provider of ETL development services in the world. And this is delivering on Informatica or data stage. Further, because ETL development is now so cheap, one of my customers is going to be in the business of ERP BI product development. This is rather like what Incorta is doing. So let's deal with the first piece first. Incorta is proposing that the, quote, data warehouse, end quote, basically be an image copy of the operational data. Yes, they do offer some versioning and some other features that come with Parquet. But the basic idea is that the data warehouse is an image copy of the operational data. I'm sorry to inform Incorta and the public that we had the forerunner to this idea in 1996 and first implemented it in 1997. And I will go into that. In 1996, I joined Hitachi Data Systems, and our basic job was to sell disk drives. Given that we were selling disk drives, it made a whole lot of sense to put more data on disks and stop putting data on tapes. So we decided in 1996 that Hitachi Data Systems would propose that the staging area would be on disk drives and not on tapes, as we had previously done. This meant that we were going to roughly double the amount of disk we sold per deal. Of course, the staging area would contain tables that looked almost identical to the source systems and would simply contain 3 new flags at the back end of each record. A 4th flag was added as standard for the tables in the staging area in 2000 when I did a project for Qantas Cargo in Australia. If you would like to read about these 4 flags, these 4 flags, you can press the button below to read the blog post about these 4 flags. I've got a bit of a mistake there on the post. So there's a button on the blog post. You can press it. It will take you to the blog post about those 4 flags. So by 1997, we were already implementing as standard a relational database-based staging area that was pretty much a replica of the data that was coming to us from all source systems. This is almost exactly what Incorta is talking about doing today, 24 years later. Sure, they are talking about having a GUI and talking about having faster hardware. But what Incorta is talking about is building what we have called a staging area for the last 30 years. And we put it on disk in a relational database for the first time in 1997. In IT terms, that is ancient history. But we didn't stop just with the data in the staging area. We propagated the data to the data warehouse. We used Bill's time variance plus stability analysis models for the archival layer, and we used Ralph's dimensional models for the end-user query layer. Later, in 2002, as a result of working on the shoulders of the greatest data warehouse data modeler that I know, I was able to add one very simple idea that enabled us to store the archival layer in a dimensional model design. That man is not Bill or Ralph, just by the way. You can read about that idea on the blog post by pressing the button below. And of course, on the website, there is a button to press for that blog post. So, to summarize, by 2002, which today is 20 years ago, we had dimensional data models that could store archival data. Thus, we eliminated the need to use Bill's time variance plus stability analysis style models to archive data. We had one data modeling technique we could use in the operational data store, the archival layer, and the analytical layer of the data warehouse. By having just one modeling technique used, we were able to vastly reduce the overall cost of building the ODS, the archive layer, and the analytical layer applications. Analytical layer components. We could also build these components at a rate of about 1,000 fields from source tables per work month. In short, by 2002, the development cost of ETL systems we were delivering had reduced by a factor of about 3 over what we were doing just 10 years earlier. As I mentioned, because we were so far ahead of everyone else at 1,000 fields mapped per work month, we never bothered to try and find a faster way until 2016. And it took us until 2018 to find that faster way. The Data Vault is very well suited for businesses who have high rates of change for records of data and do not have high rates of transactions for records of data. A very good example of an industry area where Data Vault would be preferable to our models is welfare management for governments. If you are going to implement a data warehouse for a government department that manage welfare payments, you would be much better off implementing Data Vault over our models. I also wanted to give you an idea of how fast it is now possible to build a staging area. By staging area, I mean implementing the extraction processing, the delta detection processing, and the update processing from the delta detection into the staging area. This is required to add the 4 fields that we have had as a standard since 2000, as mentioned earlier. One of my customers, using CTL, built the staging area for an ERP with 35,000 fields in it in just 4 days. This was on SQL Server. This included partitioning the largest tables across multiple hard drives and their own storage groups. This was proper storage group allocations for the 1,800 plus tables. To summarize what was created: 1. All the tables were generated. 2. All the indexes were generated. 3. The staging area was built so that it would accept inputs from multiple versions of the ERP, a feature which has proved to be extremely useful. 4. All the code was generated to extract, land, perform delta detection, and forward the inserted and updated data into the staging area. 5. There is an option to detect deletes as well and mark rows as deleted from the operational system in the staging area. This is usually only turned on for smaller tables. For each source system table requires 4 tables to be created in the staging area. So the staging area had 4 times 1,800, which equals 7,200 tables created. All these tables had to be placed into the correct storage groups. All the indexes had to be created and placed into correct storage groups. There were 6 fields added to every source table as part of the process. Each source table required 7 SQL snippets to be created that must run sequentially and should only be run if the prior snippet does not fail. So there were 7 times 1,800, which equals 12,600 snippets of SQL that were generated. They were all placed into our scheduler enabled to be run with parallel streams for faster processing. When I say our scheduler, it's a scheduler that I wrote that they have. The entire processing of the deltas to the ERP and migration across to the staging area takes about 30 minutes in that particular customer. And gentlemen, the number to be very conscious of is this: all this was done in just 1 work week, just 40 hours of work. That is what the customer paid on their invoice for that work. So the situation is this. Oh, I will add that this wasn't the first time they'd done that. The guys who did that were doing a migration of the ERP, and they were building a new staging area for that migration. So they did actually already have experience in doing this, right? They didn't just walk up one day and say, hey, we're going to build a staging area, let's do it. They had already done a staging area. They had already used all my software, and they were experienced in it. And then they had a ERP migration project, and they built the staging area for the migrated version of the ERP in a week. So I just want to be very clear about what took a week, right? So the situation is this: as long as the source ERP tells you all the things you need to know, like primary keys, data types, etc., you can now have a staging area built for your ERP in about a week. Of course, the people who do that would have to check a number of items, but that's what it cost in one case I am aware of. Of course, on that staging area, you can place as many indexes as you want to improve your query performance. And if you really wanted to go faster, you can always copy it into Sybase IQ, which is a very, very, very fast columnar database. I've used Sybase IQ. It's still out there. You can still buy it. It's really fast. Okay? And you can copy a massive staging area into Sybase IQ in minutes. When I was using Sybase IQ 20 years ago on PCs, Windows PCs, it was loading 1 million records a minute. I have no idea how fast it would be loading things today. Now, because the staging area marks the rows that have been updated in the ETL processing, it is very easy to build loading programs for a Sybase IQ target that takes those rows and puts them into a Sybase IQ copy. You could do that. It would be really easy. So that is the first thing I wanted to deal with in this blog post. It is possible to build a staging area that adds 6 columns to each table for increased functionality of the staging area for a 1,800 table, 35,000 field SQL Server based ERP in a week. It's possible to do that, right? And it's possible to do that with my software that's free, okay? You could, if you bothered to download CTL, learn how to use it, you could do that in a week for free, no software cost. You can do it yourself, right? It will take longer to run the initial loading of the staging area than it does to build it. And if you ask me to do it, here's the deal. If you want me to do that, I'll do that for you for $2,000 sight unseen. If you say to me, hey Pete, I want you to build a staging area from my ERP, I'll say, send me $2,000, I'll do it. Okay, I won't do it, then bill you the $2,000. Send me $2,000, I'll do it for you. Right? So for $2,000, for all intents and purposes, that's free. Right? If you can get a staging area built by someone like me, get all the software you need to do it for $2,000, for all intents and purposes as far as companies go, that's for free. Then you can support it yourself, or you could get one of my customers to support you, right? So, if we could do these staging areas like this 24 years ago, why didn't we just stop at copies of operational data? Is it surely, Incorta in 2022 is saying a copy of your operational data is sufficient. You can put reports over that and you'll be fine. Well, we were doing that we did that for the very first time anywhere in the world, to my knowledge, in 1997. And we didn't stop there. So why didn't we stop there? I'll tell you why we didn't stop there. There are a number of reasons, 5 of them on this list. 1, you don't get to keep your history properly. 2, data within an ERP is not properly integrated and consistent. You need to define rules on how to join items. 3, data within ERPs is not subject-oriented. The data is transaction-oriented. 4, data from multiple sources do not have matching keys. Those matching keys need to be created and maintained somehow. Multiple sources other than this one ERP. Or when I did Electronic Arts, we had 3 ERP images running around the world, and of course those keys were not unique because they were running in different images. 5, data within ERPs have notoriously high rates of data errors, especially integration errors. We found out the hard way long ago that even with the best will in the world, asking questions on the staging area prior to the ETL processing was fraught with danger. We often got the wrong answer without knowing we got the wrong answer. Nothing will kill a data warehouse project faster than giving the business numbers you believe are correct that later turn out not to be correct. That happens when answering questions on the staging area, so great caution must be taken. While it is theoretically true that you should be able to answer any questions from the staging area, meaning an image copy of all data that's coming from the sources, this is not true in practice. There is one underlying very good reason for this. Source data in ERPs or any operational system is not 100% accurate. I've highlighted it, so I'll repeat it. Source data in ERPs or any other operational system is not 100% accurate. In any source system, you should expect to see errors in the data. These errors need to be corrected before you give the data to end users to query and before you create reports or dashboards for end users to use. You need to make those corrections. So let me talk about the two most common errors that occur when querying source data. 1. Accidental Cartesian products. When querying an ERP data model and formulating questions, it is extraordinarily simple to accidentally create a query that will contain within it a cross product. That is, a join that will return too many rows for some of the data in the query. These accidental cross products are extremely hard to find because it is the data inside the table that is causing the cross product. Further, such cross products usually only apply to a very small proportion of the data in the query, so the query result does not look incorrect. It has proven almost impossible to notice these errors in these queries that produce just a very few extra rows in the output result set. Further, such errors may be introduced during the normal day-to-day running of the ERP, and so reports and queries that were tested and found to be correct can become incorrect at a later date due to changes in the data. In one client I worked with, they had about 80 reports on business objects that were based on a set of replicated tables that had views over the top to enable business objects to query those copies of the production data. When we replaced these 80 reports with an underlying dimensional model, almost all of them were found to have small errors in them. These reports the reports we produced were correct. They had been living with these very small errors in their reports for years. That particular customer, when we implemented our reports and we were doing our systems testing and we were comparing our reports side by side to their previous set of reports, our reports were different and our reports were said to be incorrect. And we had to spend quite an amount of time proving that our reports were correct and the reports that they had been relying on for years, almost all of them had errors in them. Gentlemen, it is virtually impossible to build reports over third normal form or ERP style data models and not get errors in them. It's virtually impossible. It's really, really hard. Okay? So 2, dropped rows due to referential integrity failures. In all ERPs, you will find instances where data that is supposed to be available in another table as a part of a join is missing. It was not entered, it was entered incorrectly, or even it is simply delayed in being entered. When writing complex joins, this data that is missing for some of the joins is extremely hard to find. The missing data can be introduced during the normal processing of an ERP. With the best will in the world and the most painstaking work in the world, it is simply not possible to avoid these two problems occurring in the source data of an ERP or any large operational system. These problems have to be dealt with, and to the best of my knowledge, they can't be dealt with simply by running a lot of data validation routines because you do not have an answer to the question, quote, when I find an accidental cross product or find drop records due to lack of referential integrity, how do I fix that? End quote. Let me say that again. You cannot deal with this because you can't answer this question. When I find an accidental cross product or find drop records due to a lack of referential integrity, how do I fix that? The reason you don't have an answer to that question is because it has to be fixed in the operational system, if that's what you're doing. That's the only way to fix it when you're doing these image copy style data dumps. Now, 2 of the features of dimensional models are this. 1, You cannot produce a Cartesian product accidentally. Indeed, you can't produce one even if you try to produce one. So let me say that clearly. A dimensional model stops you from producing a Cartesian product. You can't do it, not even if you want to. 2. Where there is a failure in referential integrity, a zero key is placed into the fact record to mark the fact that the break in referential integrity happened. So when you're working for a telephone company and you get call records that are coming in and the customer record hasn't arrived yet, if you want to allow that to go forward, the customer key in the call record is 0. And that 0 means I don't know what customer this is for. And the customer table has a 0 record in it that says I don't know what customer this was, so we're going to join to the 0 record. Therefore, referential integrity is maintained by the 0 record. One of the many features designed into dimensional models is the guarantee that it is not possible to accidentally produce Cartesian products or lose rows due to broken referential integrity. Not possible. So it doesn't matter that, how smart or not smart the end user is, they can't produce Cartesian products accidentally, and they can't lose data due to referential integrity accidentally. Can't do it. Not have to be clever to avoid it, but actually can't do it. And this was one of the major benefits of a dimensional model, that you couldn't accidentally produce the incorrect numbers. Even if no other advantage was offered by dimensional models, this single design feature would be enough for me to insist on using dimensional models for end-user query and end-user reporting. In fact, back in the early 90s when I was first promoting dimensional models, one of the very common discussions I had with CIOs was that the data in the operational systems was simply too complicated for end users to comprehend. Therefore, giving end users access to this information without vetting by IT was fraught with danger. When I was explaining to CIOs that there was a new modeling technique that would make it possible for business users to reliably query data, I was often laughed at and sometimes even asked to finish up speaking and leave. That's the vendor equivalent of being thrown out. And yes, gentlemen, I was thrown out of some very big companies, politely of course, because I worked for IBM at the time, but I was thrown out of some very big companies for proposing this nonsensical idea of a dimensional model. That'll never work, Peter. I was literally thrown out of companies, asked to finish up my talk and leave. In the early 90s, it was very well known and very well understood that the promise of being able to copy operational data into a relational database and reliably ask it questions was a false promise. Many had tried, including us at IBM. All of us had failed. These small data inconsistencies in operational systems meant that the answers to questions asked of them contained small errors that were just impossible to find and guard against. This is why, when I first started reading about dimensional models, I knew and understood that they solved the problems of Cartesian products and broken referential integrity as a matter of data model design. As early as 1993, I knew that dimensional models were going to win the battle of the modeling techniques. And I put that out in public now, gentlemen. In 1993, I first read about dimensional models in 1991. I didn't really understand much about them. And I went to the Metaphor Worldwide Users Group in San Francisco in September 1993. And I went and talked to a whole bunch of large Metaphor customers. And they all told me about dimensional models. And I was trying to build one at a bank at the time and not having a good run of it. So when I talked to all these large companies who were all running dimensional models, because this was Metaphor Computer Systems user conference, I realized, these guys are going to win. Dimensional modeling is going to win the battle of what models are the best models. I knew that in September 1993 from the first-hand experience of talking to very large companies that had implemented them. Okay, so I just want to make that point over and above what's on the blog post. I just didn't learn how to build them properly until 1994 and 1995. So to summarize this section, Incorta is proposing that data be copied from operational systems such as ERPs across to a fast database. Then a business directory is placed over the top and that copy of operational data is made available for query. I see this to be fraught with the same dangers we well understood in the early 90s, those being accidental Cartesian products and accidental loss of records due to referential integrity failures. These will produce small errors in the final reports that may go unnoticed for some significant period of time. Once they are noticed, there is usually significant concern at all the data in the data warehouse. Further, we have the ability to replicate exactly this sort of thing today with CTL very quickly and very cheaply. One example being the creation of a proper staging area with 6 fields added to each table for an ERP with 1,800 tables and 35,000 fields in just 1 week. As I said, it took longer to run the initial load than it took to create the staging area in the first place. Now, I want to move on to more complex topics than just the very well understood issues of getting incorrect results from queries on complex ERP data models. Because I have recommended building staging areas inside relational databases since 1996, it has always been possible to query those staging areas to answer questions. It has always been possible to add indexes to speed up those questions. In short, we've been doing what Incorta is talking about since 1997, creating a queryable database that uses the data model of the source systems. I'm not saying anything to contradict that such a staging database is very useful and a very handy backup for looking into queries that turn out to be impossible to ask on the dimensional model for some reason. The argument that building ETL from a staging area to a dimensional model is too expensive is now a dead argument. I will personally guarantee to have dimensional models built for any ERP at the rate of $8,000 per 6,000 fields mapped. Okay? And I could possibly almost make that $1 a field, right? I will personally guarantee to have dimensional models built for any ERP at the rate of $8,000 per 6,000 fields mapped. It might even be cheaper. But I will guarantee right here on this blog post that it won't be more. That's about $60,000 services for an ERP with 50,000 fields in it as the base layer of data into the dimensional model. That is cheap. Gentlemen, if you've got an ERP with 50,000 fields in it, and we say, okay, for $60,000, we will build you a data warehouse, and every single one of those fields will be in your target data warehouse, and it will be a dimensional model. For $60,000, that is really cheap. If you want it cheaper than that, I don't know where you're going to get it. Since 1997, on every project I have done, I took all the fields from the ERP operational systems, minus of course the purely operational fields, into the data warehouse. This proposal of non-lossy data warehouses removed the discussion of what fields should we put into the data warehouse. What else do dimensional models give us that we don't have and can't have in our staging area? What else is there? Some more advanced things. Although I don't consider these advanced because these have been around for 25 years, right? So number one, the ability to easily introduce groupings and hierarchies. We all know that there are hierarchies in business that business people use to drill down on their data. There are time hierarchies, geographic hierarchies, product hierarchies, demographics hierarchies, and relationships, just to name some of the most obvious. In the process of going from the staging area to the data warehouse, the ETL system builds these hierarchies. if you take the Incorta idea of having these hierarchies defined at query runtime and not defined at ETL runtime, your CPU consumption will be vastly higher. 2. The ability to maintain many levels of summaries. It is stunning to me, 25 years later, that the vast majority of data warehouse architects did not implement Ralph's ideas of multi-level summary data in one fact table and multi-level dimensions in the one dimension table. The only vendor who picked up on this was MicroStrategy. This was because a number of Metaphor people trained by Ralph finished up over at MicroStrategy. However, MicroStrategy recommend each level of each dimension be in a separate physical table, and each level of each fact table be in a separate physical table. I presume that the reason this was done was because this stopped other contemporary vendors like Business Objects and Cognos from stealing their customers. Business Objects and Cognos cannot properly query the models that were created by MicroStrategy consultants. One of the main reasons that MicroStrategy remains king of the hill for the super large user base and super large volume data warehouses is exactly because they implemented Ralph's ideas of multi-level dimensions and multi-level fact tables. They just implemented these ideas in a slightly different way to secure the longer life of their customers. Dimensional models allow you to maintain many levels of summary in one fact table. Ralph Kimball's old database company, Redbrick, performed aggregate navigation on top of these summary levels, which is what made Redbrick so fast. Today, we can maintain multi-level summaries in fact tables using only SQL. If you want to read the blog post about how that is done, click on the button below. And of course, on the blog post, there's a button called Multi-Level Facts. You can click on it and you can go read that blog post. We all know that in business intelligence, we go from high-level summary data down to detailed level data on dashboards, in reports, as well as in ad hoc queries. That drill down from high level to low level is something that was observed in the 70s for business reporting. The hardware vendors like to tell you that you just need faster hardware to make this more responsive. The software vendors like to tell you that you just need their cube products like Essbase, SSAS, TM1, Cognos to make this faster. Tableau and Qlik will tell you that you need their in-memory databases to make this faster. Since I found out about how this works in 1993, I have been repeating Ralph's ideas on using multi-level dimension tables and multi-level fact tables to make these queries go faster. In fact, I have just invented a new way to query these databases that makes the levels easier to navigate no matter what tool you are using. Hooray for me! Literally, I just invented that about a year ago. Ralph and I talked about these multi-level models on the DW List forum, which is a popular forum in the late 90s, on the DW List forum in the late 90s until we were blue in the face. People just did not want to learn how to implement them. I guess Michael Saylor has been rubbing his hands together all these years that no one else really jumped on the bandwagon of building multi-level models and navigating them properly. By summarizing the data from the detailed transactions up to the higher-level multi-level summaries, it is possible to support many of the higher-level dashboards and queries from this highly summarized data. Then, as the user drills down to more detailed levels, the aggregate navigator can query the database at the level the data exists closest to the level being asked for. You can't do this with the staging area approach of Incorta because you don't have a place to store the rules for the aggregations. And you don't have the ETL processing to perform incremental updates of multi-level summaries. It should not be forgotten that if the claim is, quote, if you just buy faster hardware and more processing power, you will speed up your summarization processing, end quote, then if you apply the same amount of hardware to already summarized data, you are going to get blinding speed. More usually, companies will settle for the speed they want, and if you have multi-level summaries in a dimensional model, you are going to get much better query performance with much less hardware. meaning multi-level summaries, which cost almost nothing to create and maintain, will save you a lot of user wait time and a lot of hardware and software costs. With CTL, it is possible to add multi-levels to dimensions and to fact tables by the mere documenting of what you want in the control tables. To maintain multi-level summary fact tables in SQL, there are some SQL snippets that have to be created because we currently have not seen the value in generating those few snippets from the CTL workbook. 3. The ability to link attributes and to add attributes that are not linked in the ERP. The next section I want to comment on is the fact that simply copying ERP and source system data does not do anything for you in terms of being able to add additional attributes from other sources and to integrate them to the ERP data. A key component of a dimensional data warehouse is the ability to much more easily integrate data from other sources, including external sources to the company. The issue with many sources from many systems, as we all know, is that the keys don't match. So we have to build and maintain cross-reference tables to match keys between systems. Then we need to link them. And we all know that integers are the best type of data to use for joining tables in relational databases. So no matter what you do, we need to be able to bring data from different sources together. We need to have cross-reference tables, and the final results we are best advised to link via integers. You do not get any of these functions with a copy of data from operational systems. All these features have to be added. The customer dimension association table is a good example of how such data is brought together in an association table. This sort of data structure is not simply not possible unless you are using integer keys for data being sourced from many places to be used to profile parties, most importantly customers. It's not possible. So in the Incorta idea of we're going to take a data from a staging area and we're going to integrate it, it's not possible to do what I'm talking about at runtime because it's too expensive. Please note this is the link. Please note this is the same link as previously presented on this post, and it goes to talk on about the customer dimension association tables. Item 4. The ability to create very complex fact tables. Now I know this blog post is epic, but I wanted to be thorough. The last topic I wanted to cover are the very complex fact tables. Businesses are complicated. If you can deal more effectively with those complications, you have a better chance of being more successful in the business. In some businesses, there are some very important business processes that are best supported by some very complex fact tables. Some examples are pipeline fact tables, snapshot fact tables, plans versus actuals, period-to-period fact tables, period-to-date fact tables, and all these sorts of things. Depending on your business, these can be incredibly important and provide you with very significant opportunities for profit improvement. In such complex fact tables, you have to bring data from many transaction level fact tables and place them into one very complex fact table. It is simply not possible to do that through a series of views on top of data in a fast database. Now by that I don't mean it's slow, I mean it's just not possible. Let me give you an example from a customer I did years ago. This was a retail customer where the buyers had to negotiate the contracts for their products from the large vendors selling products. The large vendors pushed hard on margins and the retail buyers were getting beaten at their negotiation. So we decided that it was worthy building a very sophisticated tablet application that would put all the data about the relationship with the vendor the buyer needed in his negotiations on price. Meaning, sitting in the room on his tablet, he had access to everything. Because you could not be sure where and in which directions the negotiations would go, we decided to give the buyers an incredibly comprehensive suite of data. But, of course, response times had to be sub-second. So all the metrics had to be made available in just 2 fact tables, one of which had more than 50 metrics in it. It gathered data from more than a dozen different transaction tables as well as from snapshot fact tables. Everything a buyer would want in negotiation with a multi-billion-dollar multinational was at his fingertips. That application cannot be built on top of, quote, a copy of the data from the ERP running on a fast database, end quote. In fact, when we first tested creating the metrics for just 1 month, the runtime was over 4 hours. We wanted to have these metrics up to close of business yesterday. Because of how the ERP worked, we needed to rebuild the current month as well as the prior 2 months. So we were looking at 12 hours processing time just to update one fact table. In the end, I personally spent about 2 weeks rewriting this ETL into very high performance stored procedures to get them to run fast enough to be included into daily processing. You cannot get this result simply by using a, quote, fast database, end quote. If you did use that approach, you would be vastly overpaying for the processing power versus 2 weeks of development effort to speed something up that will run daily for many, many years. There are a wide variety of such complex fact tables needed in businesses. If you don't have a number of these, then perhaps you are not thinking hard enough about what would be most useful for your company. So, to summarize the whole blog post, Incorta is proposing that, quote, business intelligence systems, end quote, can be created by simply copying source data from such things as ERPs, adding a business dictionary and a few other niceties, and putting it all on a fast database. Though there is some utility in this, and many people have tried to do this, there are some serious issues that have to be handled. Issues we have never been able to properly handle to the best of my knowledge. Most notably, they are: 1. The data in ERPs is not integrated or subject-oriented. The data in the ERPs will have instances of broken referential integrity. The data in the ERPs will have instances where queries produce Cartesian products. The data in the ERPs is naturally not multi-level, so summaries are not maintained. 5. The data in the ERPs cannot be integrated with data from other systems, so that data integration has to be programmed and run repeatedly at runtime. That would seem to be a reasonably sufficient summary of the issues that we know arise from trying to query staging areas or other structures that are based on the data models of the operational systems. In the end, I think it is enough to say that over the last 40 years, many really smart people like Ralph, Bill, Charles Irby, and others took a really long and deep look at what was needed to support the management decision-making processes. They came up with variations that all come down to what can be expressed as Bill Inman's Data Warehouse 2.0. Data Warehouse 2.0 can be implemented on data vault models or on dimensional models. Data Warehouse 2.0 cannot be implemented on a copy of the operational data. Those who are looking to use Incorta might well be advised to inform themselves of what we have learned over the last 40 years. You might thank me for pointing this out one day. As ever, thank you very much for reading or listening to my blog post. I'm sorry this one is such an epic, but I thought it worth my time to put this out in the public. If people get themselves into trouble with, quote, copy the ERP into a fast database, end quote, then at least I did my best to help them avoid that. I would be more than happy to recommend any of my partners to fix any such messes. Best regards from me, Peter Andrew Nolan. So that's just on 54 minutes of recording. I'd like to say thank you very much for listening, and bye for now.